Okay, so for 5.6, we are going to connect variation, slope, rate of change. So pretty much a lot of the things we learned in this chapter come together in 5.6. And I like to use something called the rule of 4. And if you understand the rule of 4, you can get from one place to another pretty easily, because this is how questions are formatted. So a lot of the times the questions are mainly formatted using words, and this is one of the rule of 4. The other three things are using an equation, using numbers, and using a graph. Okay, so we can have the word problem, we can have a graph, we can have a table of values, and we can create an equation to model this and find out future trends or whatever the case may be. Okay, so what I like to recommend is always use the numbers first. So we always want to start with a table of values, no matter what the question is. So let's read the question. Jimmy earns $25 per day plus $9 per every 100 flyers he delivers. So what we want to do is we want to figure out, okay, so number of flyers. I'm creating a table of values here. And I'm not going to create a table of values with 0, 1, 2, 3 anymore like I did in the previous lesson, because I'm looking for every 100 flyers. So I'm going to go 0, 100, 200, 300. Okay, and this is going to be his earnings, or how much he makes, or $, whatever you want to do. So if he delivers 0 flyers, he still makes $25 a day. And if you remember from 5.1 and 5.2, this right away means it's a partial variation, because even if he does nothing, he still does not have $0. So 0, 0 is not a point on this graph, therefore partial variation. So just to link that back. If he delivers 100 flyers, I have to add 9 to the 25. So 25 plus 9, 34. He delivers another 100 flyers plus another 9, 43, 52. Okay, so it's pretty easy to come up with a table. That's why I always recommend you do it first. And plus, for the rest of your life in high school, you're always going to be creating a table of values before you learn the equation and the graph. So get used to it. Create a table of values. Now, using a graph. Once we have a table, it's really easy to use a graph. This always goes on my X. It is the independent variable. My earnings depend on how many flyers I deliver. So flyers goes at the bottom, because this is my X. And this is my earnings on this side. Okay, and I want to make sure I account for all these numbers. So if this is 0, that's 100, 200, 300, 400. I could go over, just don't go under. And over here, I'm going to want to go from, doesn't really matter, let's go by tens. Okay, as long as I can fit all the information in this graph, I'm okay. Now, I just plot points, 0, 25, this is a point right here at 0, 25. 134 is 100 in the X, 34 in the Y. 243. So I'm doing my best to kind of stay linear here. My scale, I don't have enough space over here, so my scale was kind of off. Maybe if I went up by 9s, I would have had a perfect linear relation. But scaling it is probably the most difficult part about graphing. This is what usually kids are annoyed with, is just the scale. Okay, and then lastly is 52 at 300. So I plotted all three of my points. They should be in a straight line if I got a ruler. I'm a little off because I don't have grid paper here, or else I'd be pretty accurate. I'm going to put an arrow there, and I just represented it using a graph, just by plotting these points and connecting the dots. Notice it does not start at the origin. Partial variation. Direct would start from 0, 0. Okay, so using numbers, easy. Using a graph, it's easy once you use the numbers. Using the equation is actually the easiest, but right now it's going to be the hardest. Okay, so equations are in the form of y equals mx plus b. Okay, now there's a few things we have to consider over here. First of all, this m is still our slope. Okay, and this is our initial value. Or we can also call it the y-intercept. Y and x don't move, they pretty much stay there. So if I'm creating an equation, I need to find out a number that represents m. X is always there, and then I have to add a b value. Okay, so the initial value or where this thing starts, you can look at the table of values, and at 0 is where anything starts. So we know that the initial value in this case is 25. So you could always look at the table of values, wherever the x is 0, this is your b value. Or you can look here. You can look at the graph you made. Wherever it starts, the initial value, or the y-intercept, where it intercepts the y-axis, is the b value. So I can just plug this in over here. Okay, and it's positive 25, that's why it's plus 25. Okay, so the y-intercept is generally the easiest thing to find. It's always like the fixed value from the words. You know, $25 for the day, guaranteed, you're making 25 bucks. And then this is what's changing. This is your slope, whatever's changing. It's $9 per 100 flyers. So now over here to find slope, we can go to the graph. And we can make a triangle between 2 points again. Okay, or we can make a triangle between further points. Doesn't really matter. In this case, my run is going to be 200. My rise is going to be 18. So my slope is going to be 18 over 200. And this can reduce to 9 over 100, which is what you would get if you use a smaller triangle. Okay, some people can change this, 0.09. These are both pretty good. I'm going to stick with a fraction here. I like slope as a fraction. And I'm going to plug it in over here. This is 9 over 100x. Okay, so anytime I'm looking for my slope, the best thing to do is use your graph and create a triangle and find the rise over run. Okay, some guys can probably answer this question using the decimal. They're going to prefer this. Okay, so this means for one flyer. You know, we know it's $9 for 100 flyers. This means it's 9 cents for one flyer. So now if I plug in 100 into x, I get 100 times this is 9 plus 25, and I get the correct answer, 34. If I plug in 300 into my equation, I'm going to get 300 times 0.09 plus 25, I'm going to get 52. Okay, so the equation can help us solve for 1,000,000 flyers, negative, if negatives exist, I can plug in negative values. There's a lot of functionality with an equation. So this is always our main goal. Word problems are given in words. We transfer them to numbers. We like to look at the graph, but we really like to create an equation. Okay, so this is the rule of 4. We like all 4 of these things, and we want to be able to navigate through these 4 different things very easily.